Hi guys, in this series of videos we'll be looking at deformation and elasticity, tensile stress and strain, stress-strain curves, the Young modulus, loading, unloading and strain energy, and an exam-style question.
So let's start by looking at deformation and elasticity. So when we apply a force to a material, we can deform it. We mentioned this briefly when we talked about springs last time, the idea that Hooke's law was only valid up to a certain point on the spring. If we stretched the spring too much, then it would no longer obey Hooke's law, and indeed it would be permanently deformed. And that's what we're talking about here. A rubber band is a good example of that. We can stretch a rubber band and deform it. A rubber band will normally return to its same shape, but it's actually possible that we can break the rubber band entirely by stretching it too much. The elasticity of a material is its ability to return to its original shape after deformation. So an elastic band has a high elasticity, whereas something like a plastic, for instance, once you stretch and deform that, it will no longer return to its original shape. To begin, we just need to discuss a little bit about different types of deformation. So we'll just do that quickly here. So deformation that stretches a material is tensile. And deformation that compresses an object is compressive. That one's a bit easier. And that's just an example here. So here we see we're stretching this box, we're pulling up on it here and down on it like that. So that's tensile, that's because indeed that's giving us a tension. And the other way round, if we push on that object instead, then we are compressing it, and that's a the compressive deformation. We're only going to be interested in tensile deformations. So from now on, we're only going to look at these tensile deformations. So the first thing we need to know is that we need to have a standard way of talking about this kind of thing. By that I mean that it's not very good for you to come and try and talk about the specific way that a metal, for instance, will react to tensile stress and tensile strain, as we're going to see in a moment, without specifying something about the material you're looking at in terms of the specifics. As in, are you looking at a really thick piece of metal wire? Are you looking at a really thin piece of metal wire? Are you looking at a long metal wire, a short metal wire? So if we're going to talk about how things react to stress and strain, we need to include those things. So when we talk of a material, let's say a metal wire, it's important to know that how it deforms will depend on its properties like area and length. So here this is a thick one, and it's much longer than this thin one and shorter one here. Clearly how this one reacts to being stretched with the same kind of force is going to be different to this one. So we're going to try and standardize it, and that's the important part about this. It's just about making it so that you don't need to know the specifics of the metal wire you're talking about. You can just come up with these quantities that work for whatever size or shape of metal wire you're dealing with, and that's what we're going to go for here. So we make our results general by considering tensile stress and strain.
Hey guys! To continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.